IMAX is really complicated for an astronaut because it's big film and it moves fast and it takes a lot of setup, and they had some outside and some inside. I filmed IMAX on both of my previous flights. It's really complicated to put together, but there is nothing that brings you to space, that makes you feel like you're there, like IMAX films. It's as close as you can get. These are the two spaceships that take us to orbit. I'm going to wander around here. The one on the left is the Soyuz. That's the Russian spaceship that has flown a little over 100 times, this one here, and it has a crew of 3 sitting up inside this little capsule. They launched from Baikonur, Kazakhstan, and that has been the vehicle that has taken people to Mir and to the space station. Can you turn that around, please? Mir and the space station for the last 30 years. This is of course, the American Space Shuttle, and it has been the vehicle that has taken 75% of all people to space that have gone. It has been the great lifter in human history that has taken people to orbit, is the Space Shuttle. And all Canadians flew on the Space Shuttle, including Mark Arnault on his 3 flights, except on the last Canadian to go to space, which was Bob Thirsk, and he rode on board the Soyuz as a crew member, training, living, working in Russia, and eventually going down to Kazakhstan to launch. And all Canadians from now on, for the several years to come, including one of you, if you fly in space, will probably fly on board the Soyuz. Great little spaceship. And the next launch is coming up shortly, within a month or 2, to take the next crew up to space station. On my very first flight, I went to the Russian space station, Mir. And when we were docked with Mir, it had been years and years of work, and we docked our spaceship, Atlantis, to the space station Mir. It had appeared like a star, and we had slowly approached it and finally come up and docked with it, and our 2 vehicles were attached. But we still had to open the hatch. And we equalized pressure between the 2 spaceships. We could look through the little window at each other. I could see Sergei Avdeev and Yuri Gidzenko on the other side, looking through at me, and we had our international crew on our side. And we were waiting for the pressure to equalize. But finally, Sergei on the other side, he knew that the pressure was almost equal, and he was kicking on the hatch, trying to get this open so that we could be together and that we could float inside Space Station Mir. And finally, the hatch popped open, and we had salt and we had 3 flowers, and they had salt and bread, and we met inside the docking module, and then we floated into Space Station Mir. It was really a historic event with the shuttle and station. It was a very strong professional event because we were doing something very difficult for the first time, but it was a really strong personal event for all of us to be together in that place after having trained and come from all around the world. This is what I wanted to show you, the shuttle launch. And, watch the crew shake up here with the power of the vibration.
They're coming up. I see them all coming up. 3 at 100. Approach 106 auto. Over the tower. Waiting for the rest. 104.
And you're weightless the whole time, which is the gift that keeps on giving. It's a toy that never goes away, being weightless. It is just so much fun to be able to fly and float and tumble, do 1,000 somersaults, and close your eyes and picture as if you are falling off a building or falling forever. And that's a typical crew up there. These guys were up there about a month ago on the shuttle flight that just came back. And I find it interesting to look at because it's really just everybody from Earth. These are people from all different backgrounds, they speak different languages, multiple countries, all different cultures. But this is how we are exploring the universe now. Spacewalking is one of the other very complex and actually fairly dangerous things we do up there. As was mentioned in the outset, I've had a chance to do this twice, in fact the first Canadian up, and it's a wicked environment to work in. Not only are you weightless, but you're wearing a balloon. So every move you make with your arm, you're working against the resistance of your suit. The temperatures are horrible. It's plus 150 C on my right shoulder and minus 150 C on my left shoulder. And you're hit by micrometeorites all the time. And if you lose your grip, if you slip off the station or pop out of your foot restraint, then you'll float off forever. So we wear a little jet pack on our backs. There's a thruster, there are 4 thrusters there, so that if we did float off into space, I could deploy a little joystick and fly myself around as a one-person spaceship to grab back onto the space station before I ran out of fuel. And it's hard to train for. Please, Anna. So we train underwater. It's the best simulator we could come up with. And the guys, you'll see this in the movie, the Hubble astronauts did hundreds and hundreds of hours with a Hubble simulator underwater. We put just enough weight on the suit that it doesn't float and it doesn't sink. It weighs over 100 kilos, so they lift you with a crane, put tools in your chest that don't float and don't sink. Next, please. And we just, in this gigantic pool that is down in Houston, Texas, there's also one in Star City, Russia. We have a whole space station and a whole space shuttle. And there's the Hubble Telescope actually in the back of the space shuttle. Next, please. And we invent how to do this. Because if someone tasked you as your grade 12 graduation project to go build a huge robot arm onto the space station, what would you do? How would you know what to do? You know, who are you going to ask? You have to invent the whole thing. We actually had to go build the models. We had to go talk to the model makers to build the models so that they would work in the pool so we could develop the techniques to then go do it for real. So it's very much an iterative, long process of development and training.
Astronauts train all around the world, and we train in simulators in Star City, Russia, in small towns in Japan and Canada, and down in Houston, Texas. And there's a huge underwater simulator in in Star City. There's a huge underwater simulator in Houston, and that's our kindergarten for astronauts, Детский сад, where we get ourselves ready to fly in space. And we spend hundreds and hundreds of hours, weeks and weeks underwater, not just training, but inventing how to do it. You have to not just look in a book and say, okay, I need to follow these instructions. You need to write the book on how to do these things. And the movie, I think, really takes you through that process of having the astronauts given the challenge of picturing themselves, okay, I'm not underwater, I'm not in Star City, I'm not in Houston, I am in space. Okay, so what do I need to learn? What is going to be different? What can I pick out of this? How can I make it realistic so that when they open the hatch on orbit, they float out into the payload bay of the shuttle, there's the Hubble telescope there looking at them, that it feels familiar, that they feel confident and competent, and the success that they had doing some extremely delicate tasks with their fingers, I think really shows that the simulators that we have and the training and preparation we have is excellent, and it made them ready and able to go do something that is just barely possible.
What I'm doing here, I wanted to be able to work and use both hands. So I have my feet locked into a foot restraint. I have a tether, you can just barely see my tether floating there, so that if I slip out, it'll at least keep me from floating away. And it frees up both my hands. And this is Canadarm2 that we built during my flight up onto the space station, as we bolted it together and hooked up all the wiring and brought it to life.
The Hubble telescope has been one of the greatest human inventions ever. It has taught us things that there's no way for us to figure out here on Earth. It gets above the air so we can see into the universe with crystal clarity. It has sensors on it that by using astronauts and shuttles we have upgraded over the last 20 years. We've improved it, we've brought it up to date, and it has taught us the age of the universe. It has shown us planets around other suns. When one of our telescopes on Earth thinks it sees something interesting, we turn the Hubble telescope to look at it to see what's really there. It is just a tremendous time machine in that it shows us the history of the universe. It shows us the things that are going on right now that we just have no idea how that can be happening. And it also shows us the whole life and death of stars and galaxies, and we can see what's happening with our own sun and what's happening with the galaxy around us. It's a tremendous human achievement, a balance between robots and people, and given us insights that there was just no other way to achieve.